Anti-differentiation. So what do we have in this section? We have the anti-differentiation is the backwards of derivatives. So when we found derivative, let's say y equals x squared, y prime was 2x. What we are going to do here is to go back. If I give you 2x, how to get me x squared? Okay, and to do this, we introduce this symbol here called the integral sign, x to the m dx. This is an integral sign. It's a stretched s. The formula is defined as x to the m plus 1 over m plus 1 plus c. So this sign is an integral sign. So you say the integral of x to the m dx. So what we did, the formula says you add 1 to the exponent, divide by the same number. So for example, if I want to find x dx, what would that be? Well, there's a 1 there. X, we add 1, same number plus c. X squared over 2 plus c. Why do we put the c? Well, this is how we check the answer. C is a constant. To check if you got it right, you take the answer that we got, which is x squared over 2 plus c, and differentiate it, find the derivative. You should get the integrand is called the x. If we get x, then we are on the right track. So let's see, how do you differentiate this? You can rewrite this as 1/2 first, plus 1/2 x squared plus c. Then the x squared, the derivative of x squared is 2x. Derivative of c is always 0. It's a constant. Cancel, so you get x plus 0. So this means we are on the right track. Try this one first. So for this one, if you try it, it should be x to the 4th over 4 plus c. C is a constant. Next one, which function, if you differentiate, you get ex. That's ex. Remember, the derivative of ex is ex. So the integral of ex is also ex. For 1 over x, what is the function? If you differentiate, you get 1 over x. It's absolute natural log of absolute value of x. If you guys remember this. The derivative of natural log of x is 1 over x. Backwards would give us natural log of x. How about 4x cubed dx? So for this one, the first thing is I see a 4 in the front here. You can take it outside. 4, the integral of x cubed is x to the 4th over 4 plus c. And notice you can cancel the 4s, you get x to the 4th plus c. Next one, x to the negative 3 dx. So again, we add 1 divided by the same number. X to the negative 2 over negative 2 plus c. So we can bring that down, the x to the negative 2 down, to make it positive. There's 1 left. So make sure no negative exponents in the final answers. Integral of 1 over x to the 3.5 dx. So what's the first step here is to rewrite this by bringing it up. When you bring something from the top down or bottom up, it switches the sign of the exponent by an algebraic property. Then we have to add 1 to this, divide by the same number, plus c. Then 1 over negative 2.5 x to the 2.5 plus c. We have some properties about the integrals to introduce. First property, if you are integrating a function like this, like the one we did earlier, x dx or x cubed dx, and they are multiplied by a constant k, you can take the constant out first before you integrate. So again, k is a constant. If you're integrating a sum or difference of more than one function, say two functions, plus or minus, you can split it up, the integral of the first one dx, plus or minus the integral of g of x dx. This works only for addition and subtraction. It doesn't work for multiplication. To apply these properties, let's try to integrate 3x squared plus 8x plus 4 dx. Okay, so step by step, the first we use property 2 to split this into 3 integrals because I have 3 functions. Then by property 1, I see some constants like the 3 take it outside, the 8 take it outside, the 4 take it outside. The x squared becomes x cubed over 3. The x is x squared over 2. The integral of 1 dx is a 1 dx. It's the function that you differentiate, you get 1 is x. The root of x is 1. Plus c. So that gives x cubed plus 4x squared plus 4x plus c. One thing to know, if we're integrating ex dx, we said it's ex plus c. But how about if there's another number like mx, means 2x, 3x, how do you do it? The shortcut is 1 over m, that function plus c. So if I want to apply it to the integral of e to the 7x dx, how do we integrate this one? Well, by the shortcut is 1 over 7 e to the 7x plus c. Let's look at more difficult one. Integral of this. The first thing comes to mind is to split this into 3 separate integrals. Take the 7 out. Take the 8 out. 5 halves. The first one is natural log of absolute value of x. Next one, there's a 4 there, so you do 1/4 e to the 4x. This one, you have to add 1, divide by the same number, plus c. Don't forget the plus c. This stays the same. This is 2e to the 4x. 7 halves here, and there was 7 half in the denominator, becomes 2 7ths plus c. Another kind of question, find a function f such that f prime of x is x minus 4 and f of 1 is 5. So they give us a condition here. So we need to go from f prime to f. So always when you go from f to f prime, that's called derivative, this process. If you go from f prime to f, it's called antiderivative. So for this one, to go backwards, we integrate both sides of that equation. We'll put an integral like so. And the integral of f prime is kind of like it cancels each other. It's kind of like when you do the square root, when you square it, you get x. Same thing here. When you do integral of f prime, it becomes f of x. This one you can split it into 2 integrals. Keep this the same. This is x squared over 2. This is 4x plus c. But notice something, they give us a condition. F of 1 is 5. This means when x is 1, y is 5. So substitute x1 and set this equal to 5. That will help us to find the c value. 1/2 minus 4 plus c. Subtract 1/2 and add 4 to get c by itself. That's 9 minus 1/2. So c is 17 halves. Then I can go back to the equation on the top of this page and replace the c value with 17 halves. We'll give another example similar to this. We need f of x if f prime of x is x squared plus 8 and f of 0 equals 10. We can move on into this. we need to integrate both sides. Dx. So this is f of x equals x to the third over 3 plus 8x plus c. Don't forget the plus c. And what we need to do here is substitute x equals 0 and y 10. So 10 equals 0 cubed over 3, 8 times 0 plus c. So c is 10. Then you put it back in to get the function f of x, which is x to the third over 3 plus 8x plus 10. Next example here, it's more of a business example. Solid Rock Industries determines that the marginal cost C prime of producing the X climbing harness is given by C prime of X equals X cubed minus X. They want us to find the total cost function C, assuming C of X is in dollars and the fixed costs are $6,500. So they give us C prime. They want us to find C. So how do you find C from C prime? We integrate both sides of that equation. So on the left side, the integral of C prime is C of X. On the right side, we split it into a difference of two functions. Then you get x to the fourth over 4 minus x squared over 2 plus c. Then they said a fixed cost of 6,500, that's the constant. So I substituted C with 6,500. So this is the function that gives us the cost in dollars of whatever item you're trying to buy or whatever you're trying to get. Any questions?